Hi guys, sorry to interrupt your video. Just a quick plea, subscribe to my channel please. If you haven't done it already, subscribe. Tell your friends, subscribe. Thanks. Horses, gears, why, when. This comes into handy when you're trying to work out what's actually going on. Back to the engine. An engine basically is a source of power. And what happened was, years and years ago, when they first started off, they had to sell cars or horseless carriages, which became shorter and be turned into a car, so it was a horseless carriage originally. To sell it to the locals, they worked out how much energy one horse did to move a known weight over a known distance, and that became known as 1 horsepower. So when they were selling their car to the local people, they would say this engine has the equivalent of 3 horsepower, which is why we measure engines in horsepower. The more horses you have, the more power you have. But of course you are limited to top speeds. Let's say a horse's top speed is 40 miles per hour. And then if you had a lot of horses, you could get to 40 very quickly, but you would be limited to 40 miles an hour. But if you put that 40 miles an hour into a gearbox and had a 2 times multiplier, you could be doing 80 miles an hour. Put the horses on a treadmill, for instance. So, what you want to do is you want to think about the revolutions of the engine as a multiplier of horses. Let's say we have a 100 horsepower engine and it tops up at 5,000 RPM. That's as fastest that the engine could rotate. We could say therefore that at 1,000 RPM we have 20 horses, but at 5,000 we have 100 horses. So as the revs increase in speed, we get more horses, and what happens is the horses that you gain appear around the car. So you've got your car, there you go, there's a car, and if I have a few horses, they're around the car, and they're tied to the car. And what happens is, as you push the accelerator, you move the horses to the front of the car, and when you take your foot off the accelerator, they go to the back of the car. When you push the accelerator, they're very keen to get going, but when you take your foot off the accelerator, they're also very keen to stop. So maybe they're going to a Justin Bieber concert or something. And if I only push my accelerator halfway down, then I've got some at the front, some at the side, some at the back, and you can just move. This is how you could think of it. So the revs that you have on an engine mean that you have a number of horses. So if I had 3,000 RPM, I would have 60 horses in this example. But depending upon how I push the accelerator, I decide where those 60 horses go. So if I push my accelerator all the way to the floor when I have low revs, I put just 20 horses on the front of the car. But as the car gets faster, the revolutions of the engine increase. That creates more horses. So all of a sudden I get loads and loads and loads of horses. And the more horses you have, the faster the car then accelerates. So as your revs increase, your rate of acceleration improves. Problem is though, just like real horses, you get power that you can use, which is a good thing, but you have to run them, so it costs you food in hay, in this instance diesel, but you also get more emissions. So horses fart a lot, cars emit CO2 and such forth, and there's noise pollution. A lot of horses in a field are all frolicking around, being idiots, and they make a lot of noise. One horse in a field is very quiet. Just like a car, if you have a car at a low rev just going past you, it goes, you can hardly hear it. But when you've got a car screaming, you can hear it from miles away. So the higher the rev, the more noise pollution we get as well. So you get more pollution, it costs you in your pocket because you're burning more fuel, but you do get more power. So you've got to decide how many horses you need to do the thing that you want to do. If you were just driving along a road, it was a flat bit of road, you only needed a few horses just to beat the wind resistance or the rolling resistance of the vehicle. You could then decide, well, I only need 10 horses, for instance. So we go back to there. If I was at 1,000 RPM, I have 20 horses, but I would only push my foot halfway down on the accelerator to move 10 to the front of the car, you see, and then that would beat everything I need. Of course, I could come down the road at 5,000 RPM and I have 100 horses, But why bring 100 if I only need 10? I'm just burning extra fuel, making more pollution, making more noise. Equally, if I was going up a steep hill and maybe I needed 40 horses just to pull me up the hill, if I went into a gear that equated to low revs, then I wouldn't have enough horses to get up the hill, and the car would just get slower and slower and slower until eventually I would stall the engine. So we pick a gear, and if you remember earlier on the diagram, the gear meant that the clutch on the gearbox spun at a certain speed, and if I join that to the engine, it makes the engine spin at the same speed. But the engine, now it is spinning at that speed, creates horses. And so I can utilize those horses and push it through the gearbox, and away we go. So on a flat, 10 horsepower, I could only push the accelerator a little bit if I needed to. I could bring a lot of horses, but then I'd only have to push the accelerator a teeny weeny bit, but it's very, very wasteful. The same thing applies when you're going downhill. It's known as engine braking. So when you take your foot off the accelerator, the revs are set at whatever rev you supplied, but they will try to drop back down to 800 RPM where Jeeves takes over. So that is the engine slowing, and a byproduct of the engine slowing is that if it is connected to the car, if the engine slows, it also tries to slow the car. So therefore the engine is braking the car effectively, but only down to idle at 800 RPM. At that point it will just pull you at the corresponding speed depending upon what gear you're in, 5, 10, 15 miles an hour. But engine braking is a very useful thing. So if you had a 50 horsepower hill trying to accelerate you down, this gear would give me this rev, which would give me this many horses. Depending upon how I push the accelerator, I can use some of them and it will give me a good or bad result. So in this instance I needed 50 horsepower. The only time I'm going to get 50 horsepower is if I was in first gear, because second gear would only give me 48, and away we go. You could do it for an overtake, for instance. If I stayed in a low gear, I would get a lot of horses, which would be fantastic for acceleration, but I would be limited by my top speed on the engine, so second would be better. So I get a lot of horses, and as I accelerate, this would get faster and faster and faster, so I'd get even more and more horses, so my acceleration would get better, and I'd go out and then whoosh past the car and back in. If, however, I had a high gear, because a lot of people think I want to go fast, go to a high gear, all it does is the higher the gear, the lower your revs, the fewer horses you have, and your acceleration will be terrible. So high gears are only good when you have attained the high speed that you want, because what they do is they reduce your revs, and if you reduce your revs you burn less fuel. So we use high gears to cruise at higher top speeds, but we use the low gears to get there quickly. Brakes. Brakes slow the wheels. The brakes are on the wheels, they're not on the engine. If I brake the car itself, then the speed of the car will slow and slow and slow and slow and slow until I come to a stop. One of the questions in the theory test is that you're going down a steep hill, you realise that your brakes aren't working as well. Should you go down to a lower or higher gear? Now, as we have discovered already, if we go down a gear, we get higher revs. Higher revs gives us more engine braking if we were going downhill by taking our foot off the accelerator, because we tie the horses to the back of the car, which means we need to push the brake pedal less. Now, reason brakes stop working is because they overheat and expand, and the brake material cannot brake properly. So we need to keep the brakes cool. So one of the theory test questions is, you're going down a steep hill, you notice your brakes aren't working, should you go down a gear, up a gear? You want to go down gears, that kicks up the revs, that gives you engine braking. That means you can then take your foot off the brake pedal because the engine is controlling the speed of the car. That in turn cools the brakes because you're not using them anymore, and so then when you reapply the brakes, they come back again. One of the questions is about a ford. Now, a ford is a road where a river flows over the road itself. You often get a marker point that shows you how deep the water is. And if you take your wheels into the road, of course they're going into a very deep puddle. Two types of brakes on a car, one that clamps like this, and another which is a disc and a drum, which basically is a bowl with discs that push the outside edges, so it goes like that and it tries to brake rather than clamping something from above. If you have this type of brake with a bowl and you go into water, this is going to fill up with water, and then when you put your brakes on, it's full of water, so you don't brake very effectively at all. And this is why the theory question is, you've gone through a ford, what should you do next? The answer is apply your brakes, dry them off a bit. You've got to try and squirt the water out, warm them up, turn it into steam, do whatever you want to do. But basically try the brakes to get rid of that water out of the bowl, and then you can continue driving along the road. So always try your brakes after you've been through a ford. I hope that helps. Lovely to see you, darling. Lovely to see you.